Hello, my dear friends. So, summary of the last lecture, we have discussed about the origin of quantum mechanics and black body radiation, and today we will discuss about the photoelectric effect. Photoelectric effect is the key point which originates the quantum mechanics. The starting of the quantum mechanics is from this point, that is the photoelectric effect, which was firstly discovered by Hertz in 1887, and he described that the electrons were ejected from the metal surface by incident the light on its metals, then the emission of electron was formed from that metal. Then after that, in 1905, Sir Einstein do the practical experimental work on the photoelectric effect and gives some key points on that photoelectric effect, and he was briefly discussed about this photoelectric effect. Which are that point and how is it actually work? They will given. These are the 4 points which are very important for this photoelectric effect. All photoelectric effect is dependent on these only 4 points. Now we will see the figure. After that we will discuss one by one point, and we will discuss also the why classical mechanics is not sufficient to give this theory description by of this experiment. Now we will see the diagram. Here this is the metal, this one is the metal, and we incident the light on this metal. After incident the light, the electrons has ejected from this surface, and we will get one equation, that is kinetic energy equals to h nu. H nu means this is the Planck's constant and nu is the frequency and W is the work function. We will discuss what is work function and when these electrons were ejected from the metal. Now first point, when the electrons were ejected from the metal. So first condition is regarding with the frequency. Now if we incident the light on our metal surface, but the frequency of that light, the condition for that frequency of the light is equal to or greater than the threshold frequency of this material. If the light frequency of that light exceeds the limit of this threshold frequency, that is denoted by the nu naught, then at that point instantly emission of electrons was formed there. But now we will consider the word, that is the intensity, but the emission of electrons, that is not depend on the intensity of the light, but it depends on the frequency, and that light frequency is equal to or greater than the threshold frequency of this material. That time only the electrons were ejected from the material. Then what is the importance of that intensity? Why we use that intensity, light intensity, to in this experiment? Also because intensity is also important, because the number of electrons ejected from the metal, that is depend on the intensity of light. If you increase the intensity of light, then increase in number of electrons ejected from that material. Now we will see this frequency and this intensity. Now then also there is one important parameter regarding with the frequency. Which one is that? That parameter is nothing but the kinetic energy of the ejected electron increases linearly with the incident frequency. Means now here with the intensity, number of electrons were increases with increase in the intensity, but here if we increase the frequency of incident light frequency, then that time kinetic energy of the electron is also increases. Kinetic energy is depend on the frequency of light. Ejection of or emission of the electron, that is depend on the frequency limit, and number of electrons increases, that is depend on the intensity of light. Now these four points are clear. Now according to the classical physics told us, if we incident the light on any metal has the number of free electrons, more number of free electrons. Then if we incident that light on the metal, at that time they absorb that energy and ejection of electrons was formed. But when ejection of electron is formed, that is depend on the frequency. If it exceeds the limit, that is the threshold energy of the metal, then and then only ejection of electron from that metal, and this is failed by the classical mechanics. It do not described by this theory by the classical mechanics. Therefore we need the quantum mechanics for the description of this photoelectric effect, and therefore this is the first key point for the development of quantum mechanics. If we consider this experiment in weak intensity of light, then what happen? If weak intensity is there, but the threshold frequency, that it exceeds that limit of threshold frequency of that metal, then if the frequency of that light, intensity of that light is also weak, but there was emission of electrons from that metal, is successfully done, because ejection is depend on only on the threshold frequency. Therefore if we kept or if we consider this experiment for the low intensity, at the low intensity of that light, then also ejection of electron from the metal is also possible, but if it exceeds the limit, that is the threshold frequency of that metal. Then what is work function? Suppose we all know that number of free electrons are present in the metal, in any metal there are a lot of free electrons, and to emission these free electrons or emission of that free electrons from that metal, to by the minimum amount of energy, if it absorb that minimum amount of energy and its ejection was occurred, that is nothing but the work function for that electron. Now here the K is the h nu minus W, that is I first told you that h is Planck constant, nu is the frequency of that light, and the W is the work function. If we kept here nu minus nu naught, that is nu means nu naught is the our frequency, the here metal work function W, that is threshold frequency, nu naught is equals to V by H. This value we can put here, V minus V naught, that is the threshold frequency, and we can derive the equation for this photoelectric effect. Okay, so thank you for watching this video and also subscribe my channel.